Alright guys, so before we get to our test tomorrow, let's just kind of do this really quick review to remind ourselves of the little things we have to watch out for in order to do as best as possible tomorrow. Now keep in mind that the instructions for all these problems are exactly the same. What you are doing here is you're not really solving for anything, you're simplifying. And you're simplifying using those rules of exponents. And just like simplifying means, you're making it look easier is what you're really trying to do. Now keep in mind in problem 1, you have a base of -4 that's getting multiplied by another base of -4. Now if you remember, we can simplify this quite easily because when you're multiplying two like bases, what do you do to their exponents in order to simplify them?
Add them.
You add them. Now keep in mind that your base is going to stay exactly the same. Now remember that whenever you're dealing with a negative that's repeated multiplication, don't forget to put parentheses because that's an easy half point off that you don't want to miss. And notice here that 3 plus 2 is a positive 5, so I end up with -4 raised to the 5th power. Now keep in mind that I don't care if you know what -4 times -4 times -4 times -4 times -4 is. All I want to know is if you know how to combine like bases. So this is enough for me to give you 100% on this specific problem. Now keep in mind that this is kind of more of a straightforward one. Let's do one that looks a little bit messy. For instance, problem like number 5. Notice that you have 4 times a base of x times -3 times another base of x. Notice that all these bases are multiplying together. So this is where you have to kind of go through the garbage to figure out what you can simplify where. Now, no matter what, the first thing I like to do is just multiply the constants, the numbers. Notice that this is 4 times a -3. What would be 4 times a -3? -12. After I simplify, especially when they get messier, I like to cross them out because it helps me visually see, hey, I've simplified these, so let me go ahead and not worry about them. Now, I can see here that I have a base of x that's also multiplying a base of x. So just like above, when you're multiplying two like bases, your base remains the same, and you're going to add the exponents. 2 plus 3 is a positive 5. So notice that this problem would simplify to -12 x to the 5th. Okay? Now you can notice that these things even get even more monstrous, but do not let them fool you. For instance, look at number 10. Notice that all these again are all bases. All those bases are getting multiplied together because there's no operation sign in the middle. Now start with the constants. What would -3 times 4 be? It'd also be a -12. Keep in mind it was pretty much exactly like the constants in the other one. But that's okay. We know that those simplify or multiply out to a -12. Now notice that I have a base of a times another base of a. The base stays the same. I'm going to add their exponents. And 4 plus 4 is 8, so I know I'm going to end up with a positive 8. Now you can see here that I'm multiplying two like bases, so my base stays the same. I'm going to add its exponents. You can see here that it ends up with a -4. Because -1 plus a -3 is a -4. Now keep in mind that since I looked at this problem, I saw that, or I noticed that there were negative exponents, but I didn't let that kind of scare me. All I know is that when I multiply two like bases, I add their exponents. If they're negative, I just add negative numbers. Nothing to really worry about. Now I have to deal with the negatives because what again is mathematically inappropriate? To have negative exponents. So you have to get rid of that negative exponent. Now whenever I do that, I like to draw my fraction sign. And as I'm simplifying and not simplifying, I like to kind of just write it over on my fraction. So for instance, notice this -12 has its own exponent of a -12. There's nothing you can do to it, so I'm just going to rewrite it exactly where it was at, which is the numerator. Notice that this a also has a positive exponent, so I'm going to just write it over exactly where it was at. And then finally, I'm going to take that b and I'm going to move it to the opposite side of the fraction, which in this situation would be moved to the denominator. The action of moving it makes your exponent a positive. And that's exactly how you would solve this one. Keep in mind again that I have a game plan going down. No matter what I'm given, I'm going to simplify the constants first. And then if I am multiplying, I'm going to use the product property. And then I'm going to deal with negatives at the very end. Now keep in mind that that changes when you are dividing negatives, which we'll get to in a second. But before that, let's remind ourselves, when you're dividing two like bases, what do you do to their exponents? You minus, subtract, whatever you want to call it. Now notice here that I have a base of 2 that's getting divided by another base of 2. How do I know it's dividing? Because there's a fraction sign in the middle. Now, this one gets a little bit tricky because you always have to ask yourself, where does my base go, the numerator or the denominator? And the answer is always going to be wherever there is more bases. Now, where are there more bases, in the numerator or the denominator? Denominator, so your base stays the same. Now, I always like to visually draw that 1 if there's no exponent, so that way I can kind of visually see that there's a 1 there. And let's go ahead and do the math. 4 minus 1 is a positive 3. Don't forget, when there's nothing in the numerator, you always want to have that coefficient of 1 there, that number written there. All right, cool?
Yep.
All right. Now notice that you're also going to get to problems like 27, that when you look at the problems from the very start, you already have negative exponents. Now remember that when you're multiplying like bases, all you have to do is add their exponents. It's pretty easy to add negative numbers. Now, whenever you are subtracting negatives, it gets confusing, especially when you're under pressure of a test. So my suggestion is whenever you see a division problem, aka a fraction, just start dealing with the negatives to begin with. And this is the way you would go by it. Notice that this 3 has a positive exponent, this m has a positive exponent. This m has a negative exponent, so I'm going to move it to the top. Here I go, I moved it to the top. The action of moving it makes that exponent a positive. Now we do the same thing to the end. The action of moving it makes it a positive. And then I go back and I kind of analyze and see what is going on. And what are all these bases doing to each other? They're multiplying. Notice that this 3 is the only constant, so I'm going to write down the 3. Notice I have an m to the 1 times an m to the 3, so my base stays the same. I'm going to add its exponents, again, because they are like bases. Notice that n to the 4 is by itself, so I'm just going to rewrite it over. So again, my suggestion for you, always deal with the negatives first, because they are easier to deal with, really, when they're not negative. All right, so notice here that we do have a power raised to a power, like x to the 2 raised to the 4. Now remember, what you're doing here is that you have an exponent to an exponent. When you have an exponent raised to an exponent, how do you simplify those? Multiply. Now notice that your base stays exactly the same. 2 times 4 in this situation would be 8. And that is all you have to do. Now keep in mind that these get a little bit tricky when they add things, but don't let them scare you. For instance, number 36. Now I want everyone to pay attention and look up here, because this is where a lot of students make the same mistake over and over again. All right, so make sure you guys are up here, all eyes up here. Okay. Notice that this is 4 times x to the 0 times y to the negative 2. What is the exponent of this 4? 1. That has its own exponent. So when you look at this, this is a base raised to an exponent raised to an exponent. Another base raised to an exponent to an exponent. You can notice that every exponent gets multiplied by its exponent it's getting raised to. So this becomes 1 or 4 to the 1 raised to the negative 3, which becomes 4 to the negative 3. X to the 0 to the negative 3, your base stays the same. 0 times negative 3 is 0. Y to the negative 2 times the negative 3 is y to the positive 6. Now, looking at this here, what is anything raised to the 0?
Nothing.
Technically, it's something. It's a 1, right? And 1 times anything, it's going to be itself, so you're going to be left with whatever's left over. So you'll notice here that what you can really do is consider it nothing. Just cross it out, really. Yep.
How's it 1? Like if it's x and raised to like 0?
Why does it equal 1?
Yeah.
So let's say we have something like x squared divided by x squared. Well, you can see here that when you're dividing two like bases, you subtract their exponents. 2 minus 2 is 0. But if we look at it the other way around, notice we have x to the 2 divided by x to the 2. And what's something divided by itself? 1. So notice here that if we use the rule of transitivity, if this is equal to this and that is equal to that, that means that the 2 and that's are equal. Kind of like having 10 dimes, 4 quarters, and a dollar bill. If these two are equal, is it the same thing? Are the 10 dimes equal to the dollar bill? And the answer would be yes. This is what's called the multiplicity problem, and you do a little bit more of it in algebra 2, especially when you graph polynomials. Exciting times ahead of you. All right, so almost done. Keep in mind that although this equals 0, I let it go, but this 4 has a negative exponent. So I'm going to move it to the bottom. The action of moving it makes it a positive. But I'm not going to forget to simplify or to rewrite whatever's left over. And that is it. That's pretty much all you need. How about we try a really hard problem? Number 42. On the count of 3, what does number 42 equal?
0 or 1.
1. Remember, everything is getting raised to 0. Anything raised to 0 is 1. Notice that you only have a 1, and that's it.